Hello and welcome to this video about solving radical equations. The learning target of this video is understanding the process for solving radical equations. And so just to throw it out there, this is going to be part one of solving radical equations. Radical equations can get really complicated when we introduce two variables, the same variable but in two different parts. Today we're just going to focus on one variable being in the equation. So first of all, I want to talk about the core idea. And so when we're looking at square rooting something, we need to understand that squaring it undoes the square root. And so that is the core idea behind solving radical equations. And so another core idea that we're going to bring back into this is something that gets talked about when we're looking at how to solve simple linear equations, which is isolate and balance. And this is definitely going to help balance. This is definitely going to help us out when we start to make these more complicated and we involve a square rooted variable and an unsquare rooted variable. So I just want to remind you of those two things as we go about solving these equations. Now, as for the actual process, there are a few steps that we need to adhere to. The first step is isolate the radical. So the whole idea of squaring one side to undo a radical is only effective when the radical is by itself. After that, you're going to square both sides. And finally, solve. And so those are the three steps we'll need for solving radical equations. Again, today we're going to be looking at the more straightforward version of these problems, and then eventually we'll kick it up to where we have multiple variables, some under a radical, some not. It will all be the same variable, but we'll then talk about how you have to solve those. So let's take a look at some examples. Let's start off with something like the square root of x minus 3 minus 2 is equal to 4. Okay, now in a situation like this, we want to first of all isolate the radical. We need to get this by itself. And so to kind of borrow the idea of what we were doing with linear equations, you could think of this whole equation as a minus 2 equals 4. How would you solve for a? We're going to use the exact same process, but this time with a radical in there. So we would add 2 to both sides. Now we have the square root of x minus 3, and that's all under the square root, so that's together, that's combined. You can't do anything with that, is equal to 6. We've isolated the radical, so we're now at we're done with step 1, and we can go to step 2, which is where we square both sides. And so squaring and square rooting undo each other, freeing up this x minus 3. And then 6 squared is 36. We then add 3 to both sides, and we'll get x equals 39. Now, when it comes to square roots, you do have to double check everything, make sure it all works out. These types of problems, fairly straightforward. You won't run into too many issues, but part 2, you will run into issues. So let's just take a quick look. If we did 39 minus 3 square rooted minus 2, the question is, will that equal 4? Well, here we'll get the square root of 36 minus 2 equaling 4. 6 minus 2, and that does equal 4, so it does work out. So there's one example. Let's now go with something a little more complicated. So let's say we're looking at 5 plus 2 times the square root of x plus 1 is equal to 25. Okay, so did this with the other one, I'll do it for this one. The first step is to isolate the radical. And so think about the equation sort of being like 5 plus 2a is equal to 25, where a is equal to the square root of x plus 1. We need to get a by itself. So we would subtract 5, and then once we're done with that, we would divide by 2. So we'll do the exact same thing, but this time with the radical. Alright, so subtract 5, subtract 5. We now have 2 square root x plus 1 is equal to 20. Divide both sides by 2. Divide both sides by 2. That 2 disappears, and then we'll have the square root of x plus 1 is equal to 10. Now we've isolated, so we can square both sides, and we'll get x plus 1 equals 100. Subtract 1 from both sides, x equals 99. Again, seems kind of weird, but it should work out. And if you don't believe me, we can check our work. So we'll have 5 plus 2 times the square root of 99 plus 1, and we have to see if this equals 25. So we'll have 5 plus 2 times the square root of 100, and then that's 5 plus 2 times 10, and that does equal 25, which is what we wanted it to equal, so we are good to go. For my final example, we'll take a look at a word problem. So here's the story. The equation v equals the square root of 2.5r represents the maximum velocity that a car can travel safely on an unbanked curve when v is the maximum velocity in miles per hour and r is the radius of the turn in feet. If a road was designed for a maximum speed of 25 miles per hour, what is the radius of the turn? And so we just have to understand, this is sort of the same thing. It's just kind of cooked up into a word problem. And so the process will be very, very similar. So I'll write down my equation. They gave me 65 miles per hour, and they want me to find what r has to be. That's the question. So I'll plug in 65 here, and then 2.5r, or the square root of 2.5r. I then need to see, okay, do I need to do anything to isolate my square root? This one, it's not, there's nothing else there, so it's already isolated. So I can now square both sides. I'm going to get some big numbers here. So 65 times 65 is 4,225 is equal to 2.5r. Divide both sides by 2.5, divide both sides by 2.5. R equals 1,690 feet. And that is the radius of this turn. So just to recap how that was done, obviously you have to read the problem. You have to extract the equation that they have given you, and kind of look at that and understand what each component represents. And usually these equations, the variables are aptly chosen. So v is for velocity, r is for radius, so it's very clear what that is. Then you have to plug in a number and find the other one. And so now this one was straightforward because it doesn't have like a plus or a minus, or it's not like 2 times the square root. So I could square it right away. Other problems, other formulas, they may have another value in there that you'll have to simplify or move to the other side. If that's the case, do that, and then it's the whole thing of isolating, squaring, solving. And so to wrap everything up, there are 3 steps, and that is isolate, and I mean isolate the radical, square both sides, and solve. So those are the 3 basic things you need to do, and you need just to keep in mind that to undo square rooting something, you just have to square it, and you've undone that. So good luck with your homework. Let me know if you have any questions.